Hello, so we're going to be looking at completing the square and for these quadratics. Completing the square is kind of a really useful algebra tool if you can't recognize a factorization or the common factors and that sort of thing. So previously you've looked at quadratics like this: x squared plus 3x plus 2 equals 0. And you know, if you look at what multiplies to 2 and adds to 3, then you could find a way to simplify it into this sort of form where you've got x plus something and x plus another times x plus another thing equals 0. If we think of that multiplies to 2, well, the factors of 2 is just 2 times 1, which is 2, and then 2 plus 1 is 3. So we're kind of happy there, so we can just chuck in 2 and 1. And then if you set it equal to 0, this left-hand side, you get x equals minus 2, and then this right part of the left-hand side, you get x equals minus 1. That's a quick way to factorize if you see the factorization. But completing the square lets us go through some algebra which forces a square, a perfect square, which you can then square root and solve for x, essentially. So what I'm going to do is take the same example, but we're going to complete the square on it. Essentially, what we're going to do is we're going to split this 3x in half. And then, as you know, the final term here, 2, is made by these other terms multiplying together. You know? So 2 times 1 creates this 2 that we have in the expansion. So essentially, if we split it in 2, what we can do, I'm going to add it to both sides of this equation. So I'm going to write x squared plus 3x plus 2, as we've got before. But then I'm going to add 3 over 2 equals 0. Well, I should add it to the right-hand side, clearly. So I'm just going to write 3 over 2. But next, what might not be clear immediately, I'm going to square it. I'm going to square that term on both sides, because this is where the trick comes in completing the square. I'm now going to rearrange this to be x squared plus 3x plus this guy plus 3 over 2 squared, and then I can move my 2 just over here so it's still there, you know. And then I'm going to focus purely on this thing. I'm going to try and factorize it into something, and as I said earlier, completing the square forces a factorization. Alright, so this part I've put over in the red is going to be consumed into this guy, you know. I'm going to factorize it. I can still write plus 2 equals all 3 over 2 squared. And now I'm going to ask you, what number adds to 3 and multiplies to 3 over 2 squared? It adds to 3, and it's going to multiply to 3 over 2 squared. Interestingly, and maybe this is easier to understand once I give you the answer, but if you thought of it and you understand it now, that's great. But if you see it, maybe this will help. If you don't see it, maybe this will help. So I'm going to tell you now, this next term is 3 over 2 in both things. 3 over 2. Think about it. If I expand, you know, I do this first one, I'm going to get x squared. Do this next one, I'm going to get 3 over 2x. Similarly, do the next one, I get 3 over 2x. Do the outside, or like 3 over 2 times 3 over 2, and I'm going to get 3 plus 3 over 2 squared plus blah blah blah, all this other stuff, you know, in the blah blah blah. And then if I write that, x squared plus 3 over 2 plus 3 over 2, both times by x, is just 3x, yeah? 3 over 2 plus 3 over 2, both times by x, is going to be 6 over 2, which is equal to 3, yeah? 3x. Cool. 3x. And then plus 3 over 2 squared. Well, I don't even need to factorize or like to expand that, because in my initial it was already 3 over 2 squared. Plus dot dot dot. So I'm going to bring it back to this way, to this form, because this is what we like. 3 over x plus 3 over 2 times x plus 3 over 2 plus 2 equals 3 over 2 squared. Can't forget everything else that's in the equation. And now you see you've got something which is exact same as what it's being multiplied by. So this looks like x plus 3 over 2 all squared. Because, I could say this is a, say this is a. A times a is equal to a squared, So it's x plus 3 over 2 all squared plus 2 equals 3 over 2 all squared. Now if I subtract 2 from both sides to move this guy over, I'm going to get x plus 3 over 2 all squared equals 3 over 2 all squared minus 2. Let's clean up this right hand side. 3 over 2 all squared is equal to 3 over 2 times 3 over 2 minus 2, which is then, if you know your fraction multiplication, it's numerator times the numerator over the denominator times the denominator. So you get 3 times 3, which is 9, over 2 times 2, which is 4, minus 2. Now a simple way to deal with this 2 now is if I times, this is a trick that I like to do, times this guy. I want to subtract these as a fraction. I could convert this 9 over 4 to some like number, like, what is it, 2.25 or something, but that's, you could put in a calculator and get that, but that would be, I don't even know if that's right off the top of my head, so it's easier to make a mistake. What I can do is I can times it by 4 over 4 to get the denominator the same. Then I can add and subtract the fractions because they got the same denominator. And remember, you can always times a number by 1, which is equal to 4 over 4. So that's cool. And a number like 2 is actually 2 over 1, same thing. So you're going to get 8 over 4. 9 over 4 minus 8 over 4, that's just fractions, equals 1 over 4. And let's rewrite our left hand side. X plus 3 over 2 all squared equals 1 over 4. The next concept is very important in how do we get rid of this square. This square is a problem because I want to have x on its own equals something. If I have a number and it is positive initially, I'm going to ignore 0 because if I square 0, it's still 0. But if I have a number that is positive initially, then if I square that number, it's still positive. For example, 2 times 2 is equal to 4. It's still positive. If I have minus 2 all squared, this is going to be like minus 2 times minus 2. It's actually going to be a negative times a negative is a positive. So what's positive? It's all squared. So if I have the number and then I square it, which means it's going to times by the same number, this means the numbers that we square, I'm going to write it out very explicitly, but maybe this is obvious to you. Multiply by themselves always with the same sign, resulting in a positive number. And I'm going to say I'm ignoring 0 because if you multiply or you square 0, it's still 0. It's not negative or positive. But if you have a negative number like minus 2, Or if a number that's not equal to 0, for instance, our guy equals 1 over 4. It's not equal to 0, so that's great. So what can I do, and what do I have to deal with when getting rid of this square? If I have a number, I'm going to call it a squared. A squared equals 5. And then I'm going to square root it to get rid of this square. I'm going to a equals square root of 5. Well, I've actually missed something here, because a could also be negative square root of 5. All I was given initially for information was a squared equals 5. This was my initial question. So, if I was to square negative root 5, this is negative root 5 times negative root 5, which is equal, negative times a negative is a positive, and root 5 times root 5 is, I mean, I could rewrite the whole thing, square root of 25, which is positive 5, or you could just, however you want to do it, either way, is 5. Again, satisfies this, even though I had a negative at the front. So what do I do when I want to write a general answer? From here to here, the correct method is a squared equals 5. I'm going to square root both sides, but on the right hand side I'm going to do a plus. Oh my gosh, it wasn't there. Rewrite that. A squared equals 5, square root, but on the right hand side I'm going to do a plus or minus. This is going to cancel out this square root and the square here, so you get a equals plus or minus root 5. Now for our question, I'll just copy it down real quick. Copy, paste. For our question, it's the same deal. Square root this, that's going to cancel out that guy and that guy, but a plus or minus square root here. Cool. So I then have x plus 3 over 2 equals plus or minus square root 1 over 4. If you know your rules of square roots, you know I can break it up into this. And then I can, square root of 1 is just 1. And square root of 4 is 2. So I get plus or minus 1 over 2. Now, this plus or minus is creating our two different solutions. Remember our initial equation looked something like x squared plus 3x plus 2, I think, equals 0, I believe. Anyway, and we factorized this into this guy, x plus 2, or times x plus 1, both of those terms in brackets. And then we solved x equals minus 2 and x equals minus 1. So we had two answers. That's this plus or minus, yeah? It's going to give us our two answers. And that plus or minus only applies to the half. It's just for the half. Essentially, if I go x equals plus or minus a half, and I take away that 3 over 2 from the left side and move it over to the right hand side, which means it's minus 3 over 2, this is just minus 3 over 2. There is no plus or minus attached to it. Plus or minus is only for the half. Now from here, we get our solutions. Let's see if it makes sense with our initial answer. Because I can solve this now, and I can rearrange it so it's a bit neater. Minus 3 over 2, I'm going to put it there, and I'm going to do plus or minus a half here. So, our first solution, I'm going to take the positive case of a half. Minus 3 over 2 plus a half equals minus 2 over 2, which is minus 1. Then the next case, I'm going to do the negative 1. So negative 3 over 2 minus a half is minus 4 over 2, which is minus 2. So I've got an x equals minus 1 and x equals minus 2. And that's not lined up there, but you can see that x equals minus 2. Cool. These two guys, x equals minus 1, x equals minus 2, if I scroll up, same thing here from our factorization method. Same thing, minus 2, minus 1. So completing the square, I'll highlight the main steps in completing the square. You have a quadratic of some kind. You look at this middle term, you're going to add half of that middle term, and then you're going to square it to both sides, left-hand side and right-hand side. Then you can say this is going to force a factorization to this guy and this guy. And that term that you're looking for is actually the same thing. Okay? Don't forget to rewrite all the rest of the stuff in the equation as well. It's important. But essentially, you can go, and I showed like an explanation here of what was happening, but I would just skip this. You don't need to expand it to show it makes sense. You just go from this part, and then you can go to this part, and then skip all the way down to this. This is the next line I would write. X plus 3 over 2 all squared plus 2 equals 3 over 2 all squared. Then from there you rearrange for something that is squared. Yeah. Maybe you'll have to simplify the right hand side like we did. And remember, you can always times a number by 1. Then from here you'll get something that's hopefully pretty simple. You know, you've got fractions, but keep practicing and fractions will get easier. Remember that a number, if you square it, that's not 0, will always be positive. So if you square root something to get rid of a square root, square root something to get rid of a square, like this, then on the right hand side you must add a plus or minus square root. From there, keep the plus or minus always associated with the term that it is on, like in front of, and then just rearrange for x. From there, take a positive case and take the negative case. So this was the positive case when we let this one be this guy, and then this was the negative case when we let the negative half be the x, and that will give you negative half be accepted, I guess, and then that will give you your two answers. Cool, that's completing the square. If you got any questions or confusions about this, let me know, and otherwise, thank you. Bye.